Cambridge O-Levels Chemistry Paper 2 Theory, October-November 2025, Paper 21. Choose from the following compounds to answer the questions. Compound A is methanol because it has one carbon and an OH group. Compound 2 is ethanol because it has two carbons and an OH group. The third compound, compound C, seems like a cyclic compound and it is cyclopropane. Propane means three carbons. Cyclopropane. Propane because three carbons and cyclo because it's in the form of a cycle. And you know that cyclopropane is going to have a similar, a similar general formula to your alkenes. Alkenes and cycloalkanes have similar general formula. Alkenes. So it's CnH2n for alkenes as well as for your cyclopropane. And I don't know it, but I've seen it in recent past papers, so I'm sharing this tip with you. I am seeing a lot of questions related to cycloalkanes. I don't know why examiner, but he is testing this thing. So keep this thing in mind. That's why I shared it, that it's important to know. Okay, so if I talk about cyclobutane, it's going to have similar general formula with alkenes, so it's going to have similar molecular formula compared to butene. Butene and cyclobutane going to have same formula, but cyclo things they're saturated because they have all single bonds, and alkenes are unsaturated because they have double bonds. Don't forget this tip. Okay. Compound D is again, I guess, propene because I don't guess it, I know it because there are three carbons. There's a double bond, that is propene. In propene, you don't have prop 1 or 2, it's just propene. Because if there's a double bond here, we're going to start the counting from here. If there's double bond here, we start counting from here. Okay, then we have this thing. Let's draw it and then understand it. I know it's an ester. How do I know it? Because of this COO. So CH3, then there is a CH2, then there's a C double bond O, O, C, H, H, H. This part where you have one carbon, an oxygen bridge like this, something like this, what do you do over here? You see which part belongs to your alcohol. So this part, this entire part belongs to your acid, and this part belongs to your alcohol. So this is 1, 2, 3. Propanoic acid, and there is one carbon in the alcohol, so methanol. So what kind of ester are we dealing with? We're dealing with methyl propanoate. Then we have this entire long acid, which is 1, 2, 3, 4, 5 carbons. So this is pentanoic acid. Then we have this thing which has 1, 2, 3, 4 carbons. And then there's fifth carbon. So for 1, 2, 3, 4 carbons, and then there is this ester part, it's going to be methyl because there is one carbon in the alcohol part. This one is the alcohol part and this is the acid part. Methyl 1, 2, 3, 4. Butenoic acid. Why butenoic acid? Because there's a double bond. This is not butanoic acid. This is butenoic acid. Butuenoic acid. So if you want to be more precise, वैसे इतना चाहिए नहीं होता for your O levels, but still, butuenoic acid, because carbon-carbon double bond is on the second carbon. If you draw the structure, you realize. Let me draw the structure. So 1, 2, 3, 4 carbons. On the second carbon, there's a double bond. This is methyl butanoic. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. So understand this. So now, what is methanol? Methanol was A, right? We have done all the hard work. is manufactured by fermentation of aqueous glucose. You know that when you ferment aqueous glucose, what do you form? You guys remember ethanol? For making ethanol, you ferment glucose for making ethanol and carbon dioxide. So glucose is C6H12O6. And then you ferment it inside the absence of oxygen. And you form carbon dioxide, 2 moles, plus 2 moles of C2H5OH, which is your ethanol. So ethanol was option B. Is a carboxylic acid this pentanoic acid? Option F. Is a saturated hydrocarbon. Hydrocarbon means that nothing except carbon and hydrogen. Nothing except C and H. You can add nothing else. So hydrocarbon is saturated this. If you think that your alcohol is a hydrocarbon, you are wrong. Why are you wrong? Because alcohol contains oxygen. It's not a hydrocarbon. So write a note over here that alcohols, carboxylic acids, and esters are not hydrocarbons. Why are they not hydrocarbons? Because they contain oxygen. Achha. So now this is the saturated hydrocarbon because it has all single bonds. This is also hydrocarbon D, but it is unsaturated. So C is my saturated hydrocarbon. Is formed by the reaction between methanol and propanoic acid, methyl propanoate, the ester we were talking about. Where is methyl propanoate? This compound F is my acid, compound E is my methyl propanoate. State which two compounds have the same molecular formula. I just told you that your alkenes and cycloalkanes have the same molecular formula. So this, despite being an alkane, has the molecular formula of alkenes because it's cyclo. And if you don't get like this, you can count the number of carbon atoms. This is C3H6. And this is also C3H6. Two different homologous series, two different groups, different functional groups, everything different but same molecular formula. So that is compound C and D. A sample of sulfur was found on the planet Mars, contains 4 isotopes. Table 2.1 shows the percentage abundances of these 4 isotopes. Okay, so this is my mass 32, 33, 34, 36. Strange. And then this is my abundance in which they are present. Describe one difference between isotope 32 and 33. Number of neutrons, because the proton number is 16 for both, which is constant, but the number of neutrons is changing. So one difference is gonna be my different number of neutrons. Explain why all the isotopes of sulfur have the same chemical properties. Always remember, chemical properties of an element is determined by its electronic configuration. So over here, if I draw a sulfur atom, I have 16 protons in a sulfur atom. That means I have 16 electrons too. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. Sulfur. So for all isotopes of sulfur, maybe it be S32, 33, 34 or 36. My electronic configuration will not change. It will remain 286. This cannot change. though neutron number changes, but electrons in the outer shell, the electronic configuration remains the same, and that determines. So we're going to write same electronic configuration. Show by calculation that the relative atomic mass of sulfur in the sample is 32.9. How do you show it? You multiply this with this. So what do? I multiply 32 with 95.04 brackets plus 36 times 0.01 divided by the total sum of all the abundances, which in case of percentage comes out to be 100 upon 100. When I solve this, I should get 32.09. So that is how I'll prove to the examiner that I know. Sodium hydrogen carbonate decomposes when heated. This is our compound. It is decomposing to form sodium carbonate, water, and carbon dioxide. Figure 3.1 shows the reaction pathway diagram for the decomposition of sodium hydrogen carbonate. So this is my sodium hydrogen carbonate. It is decomposing. These are the products of decomposition. So this A represents my activation energy. I can simply tell this is my endothermic reaction. Why is this my endothermic reaction? Because my reactants are below and my products are above. So this is endothermic, and B represents the enthalpy change, A represents the activation energy. Identify the energy changes labeled A and B. You know that in an endothermic reaction, the activation energy is always from the reactants to the top of your energy hump, and your enthalpy change is from the reactants to the top of your product. So A is my activation energy required, minimum energy required by the particles in order to collide and react, and B is my enthalpy change, which is going to be positive in this case because this is endothermic. Use the same reaction pathway diagram to explain why the decomposition of sodium hydrogen carbonate is endothermic. I just told you I know it's endothermic because the products are at a higher energy level than the reactants. I tell the examiner products are at a higher energy level than the reactants. Got it? And if my reactants were at higher energy and products at lower energy, then it would have been opposite. It would have been exothermic reaction. So that's the little difference. Okay. Describe a chemical test for carbon dioxide. How do we test carbon dioxide? By passing the gas through lime water. So the test is passing the gas through lime water. And the result of the observation is that lime water turns milky. I get 0.009583 moles. I have my moles of my carbon dioxide. I have to calculate the moles of sodium hydrogen carbonate for the mass of sodium hydrogen carbonate. I know that 2 moles of sodium hydrogen carbonate form 1 mole of carbon dioxide. So the mole ratio between both of them is 2:1. And when that's my mole ratio, what do? I multiply my moles of carbon dioxide with 2 to get the moles of sodium hydrogen carbonate. So these moles are going to be multiplied with 2 Now I get the moles of my sodium hydrogen carbonate. Once I have the moles of sodium hydrogen carbonate, I know how to get the mass. Moles multiplied by mr equals to my mass. What is the mr of sodium hydrogen carbonate? Sodium is 23, hydrogen is 1, carbon is 12, oxygen is 16 plus 16 plus 16. 23 plus 1 plus 12 plus 16 plus 16 plus 16. That's how you mess up things. The MR comes out to be 84. So 84 multiplied with 0.0191667, whatever that is. 84 multiplied by 0.0191667. 1.61 grams. 1.61 grams is going to be my mass. I write it to 3SF. Fluorine, chlorine, bromine, and iodine are elements in group 7 of the periodic table. Bromine has a low boiling point. It is a liquid at room temperature. Describe the arrangement and the motion of the particles in liquid bromine. So basically, it's not about bromine, it's about the motion and arrangement in a liquid. We know that the particles in liquid have random arrangement. Firstly, they asked about the arrangement, 2 marks. First for arrangement, and the second mark is for motion. The motion of the particles are, when you're gonna write, free to move, slide past one another. So we are writing about how they move, and touching each other. So they're like close enough that they can touch each other. So all. Okay, explain why bromine has a low boiling point. Use ideas about the structure and bonding. So what does a bromine molecule look like? This is one bromine molecule that has 2 bromine atoms covalently bonded. Whenever we have to melt bromine, what do we have to break? There's some intermolecular force between the 2 bromine molecules that we have to break. We don't break the bond. This is the covalent bond. This is not broken. This intermolecular forces. So ideas about structure and bonding. We tell that bromine is a simple, that is the structure, simple molecular structure. Bromine has a simple molecular structure with weak intermolecular forces of attraction. Okay, fluorine reacts with potassium to make the ionic compound potassium fluoride. That's an ionic compound, potassium and fluorine. Okay, suggest 2 physical properties of potassium fluoride. Because that's a ionic compound, firstly we know that ionic compounds have a high melting and boiling point. Why? Because oppositely charged ions are attracted to each other by strong electrostatic force of attraction. So first point is going to be that they have high melting and boiling point. That is very important. And the second thing I know about ionic compound is that they only conduct electricity in aqueous solution and molten form. They don't conduct in solids, and the reason for that is because in solid the ions are fixed in positions, they don't move. Construct the ionic half equation to show the formation of potassium ions from potassium atoms. So potassium atoms, because potassium is in group 1, it's basically going to lose 1 electron to form a potassium ion plus an electron. Construct the ionic half equation to show the formation of fluoride ions from fluorine molecules. So over here, important word is fluorine molecules. Fluorine molecules are F2, and since they're 2 atoms covalently bonded, they're going to gain 2 electrons to form 2F negative. That is important over here. Okay, Chlorine gas is bubbled into aqueous solution of potassium iodide. So what happening is that you have potassium iodide and you're bubbling chlorine gas to it. So you're going to form KCl plus I2, 2 moles of this, 2 moles of this. What is happening over here is that since chlorine is more reactive than iodine, it's replacing iodine for potassium iodide, and iodine is being formed. Name the two products of this reaction. So one is, I have to name them, I cannot write the formula. Potassium chloride and iodine. Describe the observation made during this reaction. Since I'm producing something that's colored iodine, it's a yellow liquid. So the observation is going to be that my colorless solution turns yellow because of the iodine that's being produced. This iodine is going to turn it yellow. Nickel is a transition element. Nickel is good electrical conductivity and good thermal conductivity. Nickel is also ductile and malleable. So they've given us a bunch of properties. And its ductile and malleable state two other physical properties of nickel that are typical of transition elements. So except from this, we have to state, firstly, I can think of a very common property that they have high melting and boiling point. And why is that? Because they are metals, and metals have metallic bonds, and metallic bonds are electrostatic forces of attraction between the positively charged nucleus and the delocalized electron. So this metallic bond is a very strong bond, so it's difficult to break it. High melting and boiling points, and second is going to be high density. Okay, the physical properties of nickel can be explained by using ideas about structure and bonding. Explain why nickel has good electrical conductivity. Because of the delocalized electrons that are present inside its structure. It has free delocalized electrons. You call them delocalized because they don't belong to a single atom. When they all come out, you don't know which electron came out from which atom. It has free delocalized electrons to move through the metallic lattice to conduct electricity. Explain why nickel is ductile. Anything is ductile is that it can be turned into wires. And why is that so? Because when you're dealing with metals, you have layers of positive ions, something like this. So these are all layers of atoms which have lost their electrons. And when you're going to apply force from behind like this, what's going to happen is that, for instance, this is a layer, it can easily slide over each other without the metallic bond being disrupted. So over here we're going to write that explain why nickel is ductile. The layers can slide over each other. The layers of positive ions, you can also write that they can slide. Compound X contains nickel, carbon, oxygen only. X contains this much, carbon this much, oxygen. Calculate the empirical formula. So carbon ratio oxygen ratio nickel. So the percentage of carbon is 28.1. For oxygen, it's 37.4. For nickel, obviously we know that the sum of percentages is 100. So it's going to be 100 minus 28.1 and 37.4. $34.5. And now what do? I divide all of them by their mass numbers in the periodic table to get the moles. Divided by 12, divided by 16, and nickel is going to be divided by 59 on 28. What do you guys think? It's going to be 59 because we do it with mass number, not with the atomic number. And what do we get? So if I do it on calculator, I get that is how I've drawn it. Next part says that a sample of ethane gas has a mass of this. Calculate the number of molecules of ethane in the sample. 1 mole of ethane contains these many molecules. Moles equals to my mass upon my MR. Mass equals to 0.130. The MR of ethane gas, whatever it is, it's going to be 26. I have 0.005 moles of my gas. Now, how do I convert the moles into number of molecules? I know the formula that moles equals to my number of particles upon my Avogadro's constant, which is 6.02 into 10 exponent 23. So 6.02 into 10 exponent 23 multiplied by my moles, which is 0.005, and my moles come out to be number of particles come out to be 3.01 into 10 raised to power 21. That is my number of molecules to 10 raised to power 21. Calculate the total number of atoms in the sample of ethane. Remember, now I have these many molecules, okay? One molecule contain how many atoms? 1, 2, 3, 4 atoms. If one molecule has 4 atoms, then 3.01 into 10 exponent 21 molecules are going to have X atoms. X comes out to be 3.01 into 10 raised to power 21 multiplied by 4, which comes out to be 1.204 into 10 raised to power 22. Got it? Okay, explain why ethane is a hydrocarbon. Hydrocarbon is something that is carbon and hydrogen only. There's nothing except carbon and hydrogen. Can you see any other atom? I cannot. So, it contains carbon and hydrogen only. Suggest the observations when ethane gas is bubbled through aqueous bromine. So we know that ethane, it basically has a triple covalent bond over here, and when it has a triple covalent bond, obviously there's unsaturation, and whenever we're going to put bromine into any compound that has unsaturation, basically the bonds are going to break and the bromine atoms are going to attach all over here. So bromine initially in color is orange. So initial color is going to be orange, but after we add it, so it's going to turn colorless after all the bromine has reacted with ethane to saturate it out. Okay, so orange to colorless is going to be your color change. Ethane is formed when calcium carbide reacts with water. Calcium carbide contains the ions calcium 2 plus and C2 2 negative only. Reduce the formula of calcium carbide. It's very easy, look. 2 plus and 2 minus. The charges exactly balance out each other. Like they're equal and opposite. So it's going to be Ca, C2. The charges are balanced. Calcium has a 2 positive charge and C2 has a 2 negative charge. Both charges are equal and opposite, so they're going to cancel out each other, and the overall compound CaC2 is going to have a charge of 0. So this makes CaC2 our formula. Done. If you guys don't understand anything, just feel free to write in the comments. I don't understand this. Feel free to WhatsApp at I'm gonna give the number in the description. Feel free, okay? Ethene is used to make ethanol and polyethylene. Figure 7.1 shows the displayed formula of ethene. So basically this is our ethene. Alkenes such as ethene are manufactured from hydrocarbons such as C12H26. So what do? How do we manufacture ethene from hydrocarbons? What is the examiner trying to tell us? That there's a hydrocarbon that has 12 carbons in it, by the way. 12 carbons, and we are making a product that has 2 carbons from it. So what we're doing? We are breaking that hydrocarbon into smaller things, and the process is called thermal cracking, or you can say cracking. So either it's catalytic cracking or thermal cracking, but the process itself is cracking. You basically crack a long chain. For example, this is a long chain of hydrocarbons. What you do is you crack it in between, like you make different segments out of it, something like this. There's going to be a segment like this, and here you have 1, 2, 3, 4 small segments out of the bigger hydrocarbon. Describe the conditions used in the process. How do we do cracking? We need to give very high heat and a catalyst. So there are two conditions for cracking. Remember, to crack a hydrocarbon, we need to give it heat. So we need to heat it. And the second thing is, we need to use a catalyst. And if you want to learn the name of the catalyst, it's fine. It's aluminum oxide. Either we use aluminum oxide or we use silicon dioxide. These are the catalysts used for cracking. And heat, or you can write high temperatures. Okay, ethene reacts with steam to make ethanol. This is ethene, this is steam, basically water in gaseous form. And this is ethanol. Describe and explain the effect of increasing the temperature on the rate of forward reaction. Rate of forward reaction is going to increase. Why is the rate going to increase? Because look, rate is not dependent on the equilibrium. Over here, I want to discuss a very important concept. There are two things. The first thing is rate, and the second thing is equilibrium. And there are two different things. They're not the same things. Rate is how fast or slow a reaction is happening. And equilibrium is basically if the reaction is going to go forward or backward. When rate is going to increase, remember this, when rate is going to increase, both the forward rate is going to increase and the backward rate is going to increase. But when equilibrium is going to shift, it's going to shift towards one side. If you understand this thing about what I'm saying, you're going to understand everything. If equilibrium changes, it's going to change towards one side. Either it's going to shift forward or backward. Equilibrium cannot happen, like it cannot happen forward and backward both ways. It only happens one way. But rate goes both ways, the forward one and the backward one. Describe an aspect of increasing the temperature and the rate of forward reaction. It's simple. It's going to happen. Rate increases. Why does the rate increases? Because particles gain kinetic energy. We don't forget the basics. Increasing temperature is going to make the particles more energetic. Particles gain kinetic energy, increasing the frequency of effective collisions. And then there's one important thing as well I'm going to tell at the end. Increasing the frequency of effective collisions. And the second thing I want to tell you guys is that whenever you increase the temperature, you increase the number of particles that have energy greater than the activation energy. So, more. This is a very important, like this is the examiner's favorite line. You know, why does the examiner always ask you about the temperature? He's not interested. I'm sure he's not interested in this and this. He knows this. But the last line is kind of like that sparky line which he's interested in. More particles have energy greater than or equal to activation energy. Got it? Describe and explain the effect of increasing the pressure on the position of equilibrium. Now, we're concerned about equilibrium while keeping the temperature constant. Okay, so position of equilibrium by increasing temperature. Temperature basically by increasing the pressure. There are 2 moles of gases over here, 1 mole and 1 mole. In total, 2 moles here and 1 mole here. Whenever we increase the pressure, okay, the equilibrium moves towards the side that has less number of moles of gases. So over here, describe and explain the effect. It's going to be equilibrium moves towards the forward side because it has less number of moles. Equilibrium moves to the right side because there are lesser number of moles. Got it? Got it. Okay, ethene is used to make a polymer that's called polyethene. The polymer is used to make plastics. Draw the structure of polyethene. Your structure should include 2 repeat units. So we're gonna make first ethene. Ethene means carbon-carbon double bond with hydrogen, 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 and hydrogen. So this is my ethene. Okay, this is my ethene. I have to make polyethene out of it. Polyethene means that I am gonna break the double bond, extend the bonds out like this. This is 1 repeat unit of polyethene. I have to make 2 repeat units like these. So what I'm gonna do, I'm simply gonna take this, copy it, paste it here, and then what I'm gonna do, again copy it and paste it here. So here I have my 2 repeat units of polyethene. Polyethene means ethene has been polymerized. The double bond in between has broken and we've got 2 extension bonds extending outwards. Got it? So that's the final structure. If you don't make 2 repeat units, you're going to lose marks. Just make sure you do everything that's being said. Okay. State 2 environmental challenges caused by the disposal of polyethene. So there are a lot of problems because of polyethene. The first one is that the ocean thing, that plastic in oceans. That's a very big thing. We guys should be concerned about it. What happens is that it's a very sad thing as well. Let's just like spend 1-2 minutes discussing it. What happens is that this is your ocean. You must know it. And this is your plastic. What plastic does is, plastic is something that does not decompose. That means it cannot be eaten up by bacteria or fungi. So what's going to happen is this is not going to decompose. This is going to remain in ocean, keeps floating onto oceans. And unfortunately, there are animals in the, in the aquatic or marine ecosystem like turtles. They're going to mistake plastic for food. They're going to eat it. Then it's going to cause what you called bioaccumulation. Bioaccumulation means that the toxic substances like plastic is going to accumulate inside the organism. And then this is going to cause another problem that's called biomagnification. This means that, look, when you're small fish, these are your small fish. All of these small fish have plastic inside their body. Okay, so with black I'm marking plastic. This is plastic in small fish, plastic in small fish, plastic in small fish. Got it? When my big fish is gonna eat these 3 small fishes, like 1, 2, and 3, my big fish is gonna get this much of plastic inside it. So plastic basically magnifies from one organism to another. The black plastic got into the big fish. Got it? So firstly, accumulation of plastic in oceans is a big problem. Accumulation of plastic in water bodies. What is that called? Garbage patch, which is a very big garbage plastic patch, I guess in America or somewhere near. I don't remember the name, but you got to be careful about these things. Okay, next thing. Plastic fills up the landfill sites, takes up space because it does not decompose naturally, so fills up landfill sites. Next, ethene reacts with hydrogen in the presence of nickel catalyst. So you have ethene, and then you have hydrogen, and then you have nickel catalyst. What's going to happen? Hydrogen is going to get added into ethene, and then what are you going to form? You're going to form ethane out of it. Explain why this is an example of addition reaction. Always remember, no matter if you remember anything or not, but addition reaction is a reaction which only a single product is formed. Okay? So I'm going to write one product is formed. Draw the displayed formula of the product of this reaction. Okay, so how is the product going to form? First we have ethene. I'm doing all the things. So this is my ethene. And then I have something that's called my hydrogen, like this. And then I'm going to form the product. You only draw the product, okay? You don't draw all this stuff. What's going to happen is that okay, I'm sorry. This bond is going to break from here. When this bond breaks, one hydrogen is going to attach here, one hydrogen is going to attach here. So this was your ethene, this was your hydrogen, and this is your ethane. And you only have to draw ethane to get your marks. You don't have to draw this. I'm just telling you what's happening. This hydrogen is being added into this. And whenever something's added into something, you only form a single product. And when you form a single product, one product, that's called a addition reaction. Got it? Okay, petroleum is a mixture of hydrocarbons. Petroleum is a mixture of hydrocarbons, most of which are alkanes. Got it? Table 8.1 shows some of the unbranched alkanes present in petroleum and the number of carbon atoms in one molecule of alkane. Okay, so you have decane, that is 10, ethane 2, methane 1, pentane 5, tetradecane 14. Reduce the molecular formula of tetradecane, no problem. We are dealing with what? We are dealing with alkanes. And when we're dealing with alkanes, we know the general formula. It's CnH2n plus 2. Cn means C14 because tetradecane has 14 carbons. H2n plus 2, that means 14 times 2, 2n, n was 14 plus 2. 14 times 2 is 28, right? Plus 2 means 30. So C14H30. Isn't that cool? C14H30. You can reduce any formula of any alkane you can reduce if you know the number of carbon atoms, if you know the value of n, okay? State the name given to the alkane in table 8.1 that has the highest viscosity. Viscosity means the ability to flow. So that's a very common example that honey is more viscous. Honey is more viscous than water. Got it? Or water is more viscous? I don't know what is more viscous. But viscosity is the ability to flow. So basically, state the name of alkane in table 8.1 that has the highest viscosity, that's going to flow the least, because I said honey is more viscous. That means honey flows less. So over here, out of all of them, what is going to flow the less? That is less number of carbon atoms, because the more carbon atoms you have, the higher your boiling point gets. The more solidify you get, and the more solidify you become, the less you flow. So it's going to be tetradecane. Got it? I hope that makes sense. Tetradecane. Because it has the highest number of carbon atoms, and viscosity increases as the carbon length increases. Volatility decreases, but as the carbon length increases. But viscosity is going to increase. Flammability is going to decrease. Got it? There are things and there are differences. Got to learn. Okay. Petroleum is separated into useful fractions by fractional distillation. Explain how petroleum is separated by fractional distillation. So you have to learn the process of fractional distillation. You have to learn 2-3 steps over here. First is that you use a fractionating column. What happens is that you're going to heat the petroleum. Petroleum is going to turn into vapors. Then the vapors are going to pass through the fractionating column, and they're going to be separated on the basis of their different boiling points. So there are many good YouTube videos over here. Like, I know there are many good videos. You pass your, what do you call it? That thing, petroleum, the petroleum vapor, into your fractionating column, and on the basis of different boiling points, it gets separated. Okay, so first point is that first what we're going to do, petroleum is heated and turned into vapor. Okay, good. Vapor is passed through a fractionating column. Don't miss the steps, please. And now, the third thing. Petroleum is going to be separated on the basis of different boiling points. That's the core principle why fractional distillation works. It works because of different boiling points. Write it somewhere, okay? Okay. So, petroleum, vapors are separated on the basis of their different. Sorry if I'm a little slow. I think I am, but I just want that like the concept is clear. Over here what's going to happen is that the ones that have the highest boiling point and lowest boiling point, they're going to be arranged on that basis. Okay. Methane and ethane are both refinery gas fractions. State one other use of refinery gas. Okay, so the one use refinery gas is, I guess, heating, cooking. That's all you have to learn. So heating, cooking. Decane is in the naphtha fraction. State one use of the naphtha chemical feedstock, right? You have to learn it from the syllabus. I've learned this all from the syllabus. That is no rocket science. For bitumen, it's roads. For lubricating oil, it's lubricating machinery and all that stuff. Chemical. For kerosene, it's diesel. For kerosene, it's jet fuel. For fuel oil, it's ship fuel and all that stuff you have to learn. Okay. Anhydrous copper 2 sulfate is a white solid. State the meaning of the term anhydrous. Anhydrous means you've no water inside you. Okay? Anything that has no water is anhydrous. Anything that's hydrated is chemically combined with water. So anhydrous means it has no water. Anhydrous. Okay. Anhydrous copper 2 sulfate is added to water. Now you're adding an anhydrous copper 2 sulfate to water. You know what happens? Copper 2 sulfate is white in color, but we're going to add it to water. It's going to turn blue in color. Cobalt 2 chloride, it's blue in color. We add it to water, it turns pink. So you have to learn this. So state the color solution form. It's going to turn blue. Aqueous ammonia is added dropwise until in excess in a small volume of aqueous copper 2 sulfate. Describe the observations. Ammonia is added into a copper ion. Copper 2 plus ion, ammonia is added. Remember the observation? What are you going to form? You're going to form blue precipitates of copper hydroxide, and then those precipitates are going to dissolve in excess ammonia to form a dark blue solution. So, blue, you have to learn all this. Precipitates form. Blue precipitate forms that dissolve in excess to form a dark blue solution. Describe the observation when aqueous barium nitrate is added to aqueous copper 2 sulfate. You're adding barium nitrate to copper 2 sulfate. Look, barium nitrate, copper sulfate. Can you see barium sulfate is going to be formed? Displacement reactions, precipitation reaction. Two soluble salts over here, one soluble and another soluble, react to form an insoluble. So over here, we're going to form white precipitates of BaSO4. And you're also going to form copper nitrate, but that's going to be soluble, so we don't care about it. Aqueous copper 2 sulfate is electrolyzed separately with carbon electrodes and with copper electrodes. So when we use carbon electrodes, normal electrolysis is going to take place, but when you're going to use copper electrodes, what's going to happen to electrolysis is that it's basically gonna be copper that's gonna be, because anox, it's gonna be copper that's gonna be oxidized at the anode, and it's gonna be copper that's gonna be reduced at the cathode. Okay, so over here, if we have copper, so if, for instance, believe me for a second that this is copper, this is copper. This is your anode positive, this is your cathode negative. What's gonna happen? Copper is gonna come down from here into the solution, and then copper is going to get deposited on your cathode. So At the anode, copper is going to get oxidized. That means it's going to, oxidation is loss of electrons. Copper is going to lose electrons to form Cu2 plus 2 electrons. And then the Cu2 plus ions in the solution are going to go towards the cathode. And there, what's going to happen? Cathode pe kya hote hai? Reduction. They're going to gain electrons. So Cu2 plus 2 electrons give copper. Got it? Observations at anode. Carbon electrodes and copper electrodes. Okay, first we write for copper. Observations at the anode. What did I tell you? Anode is going to get smaller. It's going to get dissolved. So we write anode gets smaller. And at the cathode, cathode pe pink solid copper is going to deposit or it gets bigger. Got it? So pink solid. Observation means you don't have to tell about what kind of substances are you dealing with. You don't have to write copper. You just have to write pink solid. You just have to write gets bigger, gets smaller. What do you observe? Okay? Pink solid. And it's also going to get it's also going to get bigger. Okay. Now we write about observations at the anode with the carbon electrodes. If you're going to go with carbon electrons, then what's going to happen is that we're going to have copper ions in the solution. We're going to have sulfate ions. We're going to have hydrogen ions. And then we are going to have OH negative ions. Okay. Over here, out of copper 2 plus and H plus, what's going to be deposited at the cathode? Copper. Why copper? Copper is below in the reactivity series. Do you guys remember? Copper is below, so it's going to be deposited. And then out of the sulfate and hydroxide, sulfates don't discharge hydroxide. And when hydroxide gets discharged, what do you form? You form oxygen gas. And what are you going to see? You're going to see bubbles of oxygen gas. So observations at the cathode, pink solid, that's going to be copper from here. And at the anode, bubbles of a gas, that's going to be your oxygen gas because of hydroxide discharging, because sulfate is not going to discharge. So bubbles. Explain why aqueous copper 2 sulfate conducts electricity, but solid copper 2 sulfate does not conduct electricity. Okay, so aqueous copper 2 sulfate does, but solid copper 2 sulfate does not. Why? Because aqueous copper 2 sulfate has free ions. Copper sulfate is an ionic compound. An ionic compound only conduct electricity when they have free ions. So I'm going to write aqueous CuSO4 has free mobile ions. But in solid CuSO4, ions are fixed in positions. Air is a mixture of gases. State the percentage by volume of oxygen in clean dry air. Please learn it for all gases. For oxygen, as far as I know, it's 21%. For nitrogen, it's 78%. For carbon dioxide, it's 0.04%. For argon, it's 0.9% or something. Just learn all of them, please. Okay, the percentage of carbon dioxide is increasing. Yeah, we know that's called global warming. State one adverse effect of this increasing percentage of carbon dioxide. State one adverse effect of this increasing percentage of carbon dioxide. Global warming. Carbon dioxide is a greenhouse gas. It absorbs the heat, so it's going to be global warming. State one strategy to reduce this increase in the percentage of carbon dioxide. You plant trees, they're going to absorb the carbon dioxide, so it's called afforestation. You can also use less fossil fuels, you can use less cars, you can use renewable energy resources like wind and solar and geothermal and all that stuff. And HEP, hydroelectric power. Some air pollutants such as sulfur dioxide causes acid rain. SO2 causes Acid rain. Name one other air pollutant. Name one other air pollutant that causes acid rain. Nitrogen dioxides. NO2, or you can write oxides of nitrogen. Okay? The burning of fossil fuels containing sulfur in power station produces sulfur dioxide. Describe one way to reduce the emissions. Using low sulfur fuels, burning less fossil fuels. There are fuels that are called low sulfur fuels. So use low sulfur fuels. And then there's one more thing. What do you call it? Flue gas desulfurization. You have to learn all this stuff. Flue gas desulfurization. Over here, what do you use? You basically make the oxides of sulfur react with substances like calcium oxide and calcium hydroxide, and what they form is calcium sulfate or sulfite. And what you get is you basically neutralize the gas. That's flue gas desulfurization.